All right, ladies and gentlemen, in this video we are going to be analyzing reciprocal functions. Now, the parent function, that means the very basic function for reciprocal functions is y equals 1 over x. This looks just like that inverse variation where the value of k is 1. Now, there is a restriction. X cannot equal 0. The reason? Well, you can't divide by 0. If x were 0, then this would be undefined. What does that mean? That means that you have a vertical asymptote at the y-axis. Okay. Now, the basic function that we're going to look at is this. Y equals, we're going to say some number a over x. Okay, that's where a could be other values besides 1. Okay, now this has the same restriction. X cannot equal 0. Why? Because if x equaled 0, it would be undefined. Now, here's where the value for a will come into play. If a is greater than 1, not just a, but the absolute value of a. So I mean, even if it were like a negative number, if its absolute value is larger than 1, what we're going to have is a stretch. Now, what kind of stretch is this? All right, this is just a generic function, so please, nothing is measured. Okay, our original would be like this. Okay, we would have hugging the x and y axis with both x and y axes as asymptotes. Okay, that would be our original. A stretch would pull this away from the x and y axis, where it pulls it out more. Okay, it stretched it out diagonally, like following the line y equals x. It just stretched it out. Okay, that's what values for a will do when their absolute value of a is larger than 1. Well, what if the absolute value of a is less than 1? And it also has to be larger than 0. In other words, a fractional value. Okay, a is less than 1. So, when the absolute value of a is less than 1, but it has to be larger than 0. Okay, greater than 0, its absolute value. What that is, it's a vertical shrink. Okay, so what does that mean? It makes it hug that x-axis much tighter than y-axis. Okay, it sucks it in. Okay, that's what it does. So stretch pulls it out, shrink pushes it in. Okay, now what if the value of a, not absolute value, but the value of a itself, is less than 0, a negative number? Okay, well, you see how this goes like positive x and positive y, negative x and negative y, and you know a double negative makes a positive, right? Okay, well, it makes it a reflection in like the line y equals x. So instead of it going this way, it goes this way. That's what happens when your a is negative. Now, if that wasn't enough, then we're going to add what's called translations. What does that mean? Movements. Okay? If we have this, y equals, we'll just use, we can use the number a. So a over x minus h, so a horizontal translation, plus k. Now, our restrictions changed. Instead of x not being able to equal 0, x cannot equal h. Why? Well, if the value of x and h were the same, you'd get 0 in the denominator of the fraction, and that means it would be undefined. Okay, so what does that mean? It means it shifts the vertical asymptote. That's what the h does. It shifts that vertical asymptote left or right. How do we know? Well, when the value of h, well, let's look at something like this. Y equals, we're just going to use 1 for a, and we're going to say x minus 2. Okay, and let's say plus 2 for k. Okay, or let's make the k a 3 so we have a different digit. Okay, that's an ugly looking 3. Let me erase that. Better looking 3. Okay, my horizontal asymptote, I take my x minus 2, set it equal to 0, and solve for x. So when I add 2 to both sides, I get x equals 2. So what does that mean? That means it shifts to the right 2 units at positive 2. So right 2. Okay, and then this here would be your vertical asymptote, because k has to do with vertical, excuse me, it would be a vertical shift, which is your horizontal asymptote, because a horizontal asymptote would shift the whole graph up or down. Okay, so this would be up 3 units. So this number here has to do with your horizontal asymptote, because a horizontal asymptote will shift the graph up or down, and this number here has to do with your vertical asymptote. Now, what if this denominator, and we're just going to change the signs, okay? So y equals 1 over x plus 2, and then we'll say we have a minus 3 out here, okay? Well, if I took x plus 2 equals 0, subtract 2 from each side, I get x equals negative 2. So that is a shift left 2 units. Okay, and what does this do? Well, that minus will shift it down 3 units. Okay? Alrighty, have fun with these. In the next video, I'm going to actually do some graphing of these, so enjoy.